Hey guys, I'm going to use a bad word, algebra. Okay, and here's the use of that bad word. Okay, the algebra word. Okay, they're asking you to take this rule, translate this, find the coordinates of the vertices of each figure after the given transformation. In other words, they want you to find the image from your pre-image, just given the points, no diagram at all, and using the rule. So hey, let's take a look at how we do this. Let's take our first point, J. Okay, it's -4, comma, -3. And I want to find out, using this rule, what my image is. So I'm going to map on to this rule. I'm going to use it. So my x value is -4, so I replace my x value here with -4, add 5. Okay, that will give me my new x value. And I take the y, -3, add it to my rule, which is 5. So each time I'm adding 5 to each point on the pre-image to get my image, which is now J prime, which looks like this. -4 plus 5 is 1. -3 plus 5 is 2. So what this is telling me is my pre-image J maps onto J prime 1, 2. Let's take a look at our next one, which is y. Okay, it's -3, comma, 0. I'm going to apply the rule right here to it. So I'm going to take -3 and add 5. And then I'm going to take 0 and add 5 to my y value. So I'm taking my x value and moving to the right 5. And I'm taking my y value and moving up 5. Which will give me y prime, which will give me -3 plus 5 is 2, and 0 plus 5 is 5. Real hard math here. Okay, and then lastly, v is 0, comma, -3, which will map onto 0 plus 5, comma, -3 plus 5. Same rule, which will map onto v prime, which will become 0 plus 5 is 5, and -3 plus 5 gives me +2. So this will give us a new triangle. Since I have 3 vertices, it's going to be a triangle. And nothing difficult. It's just picturing this, okay, realizing what's happening here, and doing it, doing the math, doing the algebra. All right, let's do one more so you get the idea. All right, translation. Okay, I want you. No, I'm gonna write the rule down so that maybe you can see if I write the rule down and put it on top of what we're doing. You can see what's happening here. Okay, so remember what the coordinate notation tells us, that I take every single x, y value that's on my pre-image and I map it onto an image where I add 3 to my x value and add 5 to my y value, and that will give me an image. So let's do this. Alright, my point M, okay, is -5, comma, -3. It's my x and y value. So I replace my x and y value with these two values, -5 plus 3, -3 plus 5. Do the simple math, which is very simple. And it's going to give us m prime. Okay, so -5 plus 3 is -2. And -3 plus 5 gives us +2. So you just have to know how to do some simple computation. Okay, w is -3, comma, 0. Maps onto the same rule. -3 plus 3, and then 0 plus 5. Oops, okay. Okay, so -3 plus 3, comma, 0 plus 5 maps on to w prime, which is going to be 0. -3 plus 3 is 0, and then 0 plus 5 is 5. There you go. And one more, two more, okay. So what do you think this is? This is some type of quadrilateral. So this is four vertices. It's going to give us four sides. So P is 1 comma negative 1. This point goes into this rule here. Sort of like a function from last year, if you remember functions. I'm going to take 1 plus 3, gives me my new x value. Negative 1 plus 5 gives me my new y value. So it's going to be P prime. Oops. P prime. Okay, 1 plus 3 is 4. Negative 1 plus 5 is 4. Okay, and then lastly L, 0 comma negative 5. And it maps onto, okay, remember I'm going to take my x value, 0 plus 3. My y value is negative 5 plus 5. And it maps onto L prime, which will be 3 and 0. That's all there is to these. Nothing hard. It's just a little tedious, but it's good work for you. Okay, oh wow, I went to problem 6. I didn't mean to go to problem 6. I don't know how that happened. Alright, well anyway, so you don't have to do problem 1 or problem 6. You already have it written down. Okay, talk to you later. Stop.